Hey, welcome to this new section. And in this section, you will learn how to use Pandas, which is a very important Python library, and you really don't want to miss that. So, what is Pandas? Pandas is a library providing data structures and data analysis tools within Python. Or if the word tools confuses you, then you can say Pandas is a library providing data structures and data analysis code. So basically, Pandas allows you to load data from different sources into Python and then use Python code to analyze those data and produce results, which can be in the form of tables, text, and also visualization with the help of visualization libraries such as Bokeh. Bokeh, which is covered later in the course. So for now, we'll focus on data without visualizing them, and Pandas is great for that. So practically, how do we use Pandas? You learn how to open text files using Python built-in file handling methods earlier in the course. Now, what we opened from text files was just plain text. But what if you want to load text files with data constructed of rows and columns? So things get a bit complicated. But here is where Pandas comes into play. So you can probably do that using built-in Python methods that we have learned in the course. But to be more efficient, and to be much more efficient, you need to have a high-level library such as Pandas, which is able to recognize such data structures automatically. So I use Pandas for loading data from data mining activities such as web scraping. So you scrap data from a website with Python and then store those data in Pandas data frames. So you use Pandas to provide data structures for you in Python. And I use Pandas for loading data from Excel files, and also use Pandas for analyzing those data instead of using Excel. Excel can be good for analyzing a small table of data that fits in your screen, in your computer screen, but for data larger than that, you really want to use code. So you write Python code once and then you reuse it with other data as well. And you don't want to do selections and dragging and many other cumbersome operations that you normally do in a graphical based program such as Excel. So code is the way to go if you want to be efficient with data, and Python is great for that with Pandas. So you really want to get a good hang of Pandas, and you will learn that in this section and also practice it with real-world applications that we'll be building as you progress through the course. Now that's enough with words, let's go ahead and install Pandas. And you want to open the terminal, and the process is straightforward. You say pip install pandas. Now I mentioned that Pandas is a high-level library, and Pandas is based on NumPy, which you can see in here. So Pandas is now trying to install NumPy, because without NumPy you cannot use Pandas. And NumPy is a more low-level library than Pandas. We'll cover NumPy later on, but I wanted you to know Pandas first, because that is more easy to understand. So once you know how to use Pandas, then we think about NumPy, and I show you how NumPy is based off Pandas. So let's not think about NumPy now. And this was successful, but if for any reason it wasn't successful on your side, and I know that in some Windows distributions you may get an error such as this one here. So it says unable to find this bat file, and that happens because Pandas is trying to compile itself, but it cannot find a compiler. So in that case, the easiest solution that you can do is to use precompiled Python libraries, which you can find in this case in this website. So they are provided by Christoph Gölke. And you want to locate NumPy first. So here is NumPy. You click that and that goes down here. And then you want to pick up your version. So if you have Python 3.5, you'd want to go for this CP35. And then you have 32 bits of Windows and 64. So you want to pick your own bits. And so what you do is you download that, and that is a wheel file, which is the same file that you install with pip, but with pip you download it and then you install it. In this case, the download is being done manually, and then we point to this file with pip again to install it. I'll show you how to do that. And yeah, once that file is downloaded successfully, I've put it in here in my C drive, CPP, and then you want to either cd to that directory, and then use pip install, and then start typing the name of that file, and tab to get the complete file name. And yeah, now you should press enter, and that will install NumPy for you. Once you're done with NumPy, then you go ahead and get Pandas as well. Pandas, yeah, these are the distributions. Again, you get 3.5 if you have the 3.5 version for Python, and the Windows version as well, and you repeat the same process. And yeah, I hope that is clear. Once you install Pandas, then you can simply go ahead, import it, and if there's no error, then you're good to go. So that was about an introduction to Pandas and how to install it. Let's go ahead and dive into some code now in the next lectures. See you. Great. Again, Pandas is a library that provides data structures and data analysis tools in Python. So in this lecture, you'll see what I mean with data structures and data analysis. So you'll see the main Pandas object, which is a structure that contains the data. And you'll see that how we get data from this structure and analyze them. So I'll open a simple command line, and for now we'll use IPython, which is great for data analysis and working with data. But even better is Jupyter Notebook. Jupyter Notebook is like a Python shell. It's actually a combination of a Python shell and a Python editor, and it's a browser-based tool where you can write Python code, and it's very efficient, so it really boosts your productivity. But for this lecture, I want to start with simple things, so one step at a time, and I'll introduce you to Pandas using IPython only. And then in the next lecture, I'll show you how to set up a Jupyter Notebook, previously known as the IPython Notebook. So you'll set up Jupyter, and I'll show you how to work with Jupyter. So for now, let's go ahead and use the plain IPython console. Import Pandas. And yeah, normally the first thing you do is you want to import some data, let's say from a CSV file or from a text file, or even an Excel file or JSON or other formats, which we'll be covering later. But there are also other ways to create a Pandas data structure. And now, the first thing you should know is that this data structure that I'm talking about is called a data frame. So that's a special object that will hold the data. And you can create one. You can store a data frame in a variable, let's say df1, pandas data frame. So I'm creating a data frame manually, passing values manually via Python. Normally you want to use other files, like I mentioned. So data frame, and now think of the data frame as a table. So you may want to pass a list of lists, where each list will be a row of that table. So let's pass some data there, 2, 4, 6, and 10, 20, 30. You execute that, and that was successful because you didn't get an error. df1, and here is the data frame. So 2, 4, 6 is the first row, 10, 20, 30 is the second row. And these 0, 1, 2 are the names of the columns. And these are referred as indexes. So 0, 1 here are indexes for the rows, and these here are the column names. The beauty of Pandas is that you can also have your own column names, if you like. So I'm gonna call this expression again, and I want to pass here a parameter called columns, that expects a list of names, which has to have the same number of items with the number of columns that your data frame has. So if you pass list with 3 items, you want to pass 3 columns here as well. Let's say price, something random, age, and value. You execute that, and let me expand this, df1, and this time you see that you have your own column names there. Now similarly, you can pass custom names for the indexes as well, by passing index as parameter, and then you'd want to pass a list with 2 items, because we have 2 rows only. Let's say first, second, df1, and you have custom indexes. However, normally you won't have to pass custom indexes. Data normally have a defined number of columns, but the rows, you may have hundreds and thousands of rows or millions there. So you really don't want to mess up with index names. However, the feature is just that, in special cases. So there's one way to create a Pandas data frame, and you also have other ways as well, which are not very common to use, but I just wanted to know that they are there. So again, you pass a list here, and then what you could do is you could pass 2 dictionaries inside that list. So you can see the similarity. Here we used a list of lists. Here we are also passing a list object, but it's a list of dictionaries. And yeah, what you could do here is you could pass values, keys and values for the dictionary, and here as well. So let's say name John, name Jack. Execute that, df2, and yeah, this is yet another data frame. If you wanted to have more columns there, such as surname, you'd want to add here another key and value for the dictionary. So something like surname, and now if you execute that and df2, you'll get the surname column added there, but for Jack you'll get none, because you didn't pass a surname in the dictionary, in the second dictionary. So if you do the same for Jack, if you pass a surname, you'll get the value in here. So those are 2 basic ways to build data frames on the fly. And as I said, normally these values will come out of files, of CSV files, Excel files, etc. I will do that throughout the next lectures. And one more thing I want you to know is, so this is a data structure, and now what data analysis means is, out of this data structure you want to get out information. So you may want to extract, for instance, the average of all these values. So 2, 4, 6, 10, 20, 30. So here we enter the phase of data analysis. And the approach to do that is, this data frame object now, which you can see the type df1. So it's a data frame of Pandas. Now this data frame object has methods attached to it. If you do dir, and yeah, you see that it has quite a lot of methods that you can apply to it. Let's locate the mean method there. Here is mean. So what you could do is you point to df1 and then mean and brackets, and you get the mean of all the columns. And if you want the mean of the entire data frame, you could apply again the mean method after that. So what this does is it applies the mean method over this series here. So this type is a Pandas series object. Series have more or less the same methods that you can apply to a data frame. So df1 and df1.price, and you get the series of the price column. So that is also, if you check the type, that is also a Pandas series. So a data frame is made of series. And of course you can apply the mean method to price as well. Similarly, you can apply other methods as well that are available there. So max, and you get the maximum value. And yeah, that's about the introduction to Pandas. In the next lecture you will learn about Jupyter. It's very pleasant to work with Jupyter, so don't miss that. And then we'll go ahead and open data frames, create data frames out of files. So I'll see you later. Well, in this lecture I'll show you how to set up the Jupyter notebook, or Jupyter for short, and also how to use it. So far you've worked both with a Python or an IPython interactive shell, but also you've worked with an editor such as Atom. Sometimes you may have the need for a hybrid between an interactive shell and an editor, when you want to test things out, but you also want to save your blocks of code that you're writing. Because an interactive shell is great for testing things quickly, but you can save the code, and the editor is good for saving the code, but it's not great for testing things. But I can tell you that such a hybrid tool exists, and that is called Jupyter Notebook. And that is an amazing tool that will boost your productivity. And Jupyter is especially good when you're working with data, as it's a great environment to explore data, and you'll see its usefulness in just a bit. Of course, you still want to use editors such as Atom when you're working with multiple Python scripts that interact with each other. That's the case of web application, for example. When you're developing web applications, you'll have to deal with multiple Python scripts and also HTML files, CSS, and other files as well. We'll build a web application later in the course, and you'll see how Atom is good for that. But for data, use Jupyter. So Jupyter, let's see how to install it. Well, you can go to the installation, so install, and you can go through these instructions. But instead of going through this, I would advise you actually to use your command line to install Jupyter, and typing pip install Jupyter. So that will download Jupyter and it will install it in your system. And then to start a Jupyter session, a good practice is to go to a folder, let's say test3, and here you can open a command prompt, and then you type Jupyter notebook, and that will open a Jupyter session in the browser. So the Jupyter notebook is actually a browser notebook. The reason I opened the Jupyter notebook in the command line was that at least on Windows, when you do shift and then right click on a folder, your command prompt is opened in the current folder, so in this one here. And then when you create a notebook file now, every file will be saved in this directory here. Alternatively, you can open your command prompt everywhere you want, and then you can cd to the folder where you want to save your Jupyter notebooks. Alright, now we don't have anything here, so what you can do is create a notebook. And we install Jupyter as a Python library, so under notebooks we have Python 3 available. So the kernel will be Python 3. If you have associated other languages here, you'll see them under here, under notebooks. So this is an empty notebook. And this is the name of the notebook, and you can change this to, let's say, testing. Press OK. And if you go to the folder, you'll see that a file with testing name and IPython notebook extension was created. So that is created automatically every time you type something here, you do some changes or something. Now let me show you how you can work with the IPython notebook. So you can consider every cell, this is a cell, and you can consider every cell as a line in a normal Python shell. But here in this shell you can actually write multiple lines of code. Let's say print 1, and then if you don't want to execute this right away, you can press enter. So with enter you enter a new line in the cell, and then print 2, and so on. And if you want to execute the cell now, you can press Ctrl enter, and you get the output. Now if you want to create a new cell, Alt, Enter would do that. And here you can write another block of code. With Enter you go to the next line, and so on. And if you want to go to the next cell right away, so before we pressed Control Enter, now you can press Shift Enter and you go to the next cell automatically. And with Shift Enter you also execute the cell where you were working on. You can create new cells with Alt Enter, and you can delete them by pressing first you press Escape and then you press DD 2 times. DD again. So it's quite flexible. Something you should notice is that we have two modes basically. We have the command mode. So when you are in the command mode, you see a gray rectangle around the cell. And when you are to go to the edit mode, then you press Enter. So while you are focused on the current cell, you press Enter and then you edit the cell. So in edit mode, when you type things, you're inserting text in the cell. You're inserting code in the cell. Escape and command mode, DD, and you delete the cell. Alt Enter and you enter a new cell. So these are the most used shortcuts, keyboard shortcuts. But if you want to know more shortcuts, you can go to Help and then Keyboard Shortcuts, and then you see a list here. But these are good to get started. When you're done with this, you can just close a tab, and you can also close the directory tree here. So notice that Jupyter actually opens in a localhost session. And if you want to open again your notebook, so you can go here again and go to open command window here and Jupyter notebook. And here is the file, and it's just as we left it. Now, a Jupyter notebook is best used for doing explorations, and especially data explorations. So if you're working, let's say, with data analysis or data visualizations, the Jupyter notebook is perfect to use. You can use the Jupyter notebook, for example, to load a table of data in the session. And for that you'd use Pandas. So you import the library, you press Enter or Shift Enter to go to the next cell, and you press Enter again to write something. So let's say df equals to pandas.read CSV, and I have a CSV file somewhere in my system. Press Enter and whoa. So you get a nice HTML table which was loaded from the CSV file, and you can also plot graphs in the Jupyter notebook. So that's also something you're learning in the course. And so data analysis and visualizations, you can also use the Jupyter notebook for web scraping. And that is very convenient because you have these blocks of code, and then you have to continuously tweak the code. So you may want to change something here, and then you get a nice display. Not this one exactly, because this is a messed up string, but this one, for instance, you have a slider here, so you can scroll up and down inside a separate window that doesn't affect your general your main window. So I hope you've gotten a good idea of the Jupyter notebook. Just take a note of the shortcuts, of the keyboard shortcuts to execute code, the edit and the command mode, enter, escape, and enter again, and so on and so forth. And you just practice them a little bit, and you'll get used with Jupyter very quickly. See you in the next lecture. Great, now that you have a basic understanding of Pandas and you know how to use Jupyter notebooks, we can go ahead and learn how to load various kinds of files in Python using Pandas and Jupyter. So I've got 5 files here. They contain exactly the same dataset, and this is a text version, or let me open the Excel version that will show a pretty overview of the data, as you can see. So we've got 7 lines of code, including the header, and we have also 7 columns. So it's just some basic data of supermarkets, so the address, city, state, country, and the name of the supermarket and number of employees. And similarly, we have exactly the same data, but in different formats. So we have CSV, and CSV means comma separated values. So it's basically a text file where the values, the columns, are separated by commas, as you can see here. So every column is separated by a comma, but it has a CSV extension and it can be opened with Excel. So if I open this now, you'll see the same data set that you saw in the XLS file. We also have the same data in separated by semicolons, as you can see in here. And yeah, if you're working with data, you're probably familiar with these kinds of files. So this is how to store data. You need to have some conventions, and using such conventions, then you use other programs such as Python to load these data. So when you load a CSV file, Python knows that the values will be separated by commas, and it knows how to separate them. It knows how to extract values. So we'll open all these one by one. We also have a JSON file, which is yet another format to store data, and looks like a Python dictionary actually. So we'll learn how to convert them to a Pandas data frame as well. So all these will be converted to Pandas data frames. Yeah, I'll go ahead and start Jupyter Notebook. Here are my files. I'll go ahead and create a new Jupyter Notebook for Python 3. Before I go ahead and load those files in Python, there's a trick I do usually. I import OS and then os.list there, and Alt Enter, execute that. So you go to the next line, and what you get is you get a list of files and folders as well, of file names that you have in the current directory. So now I don't have to switch to my folder to look at the names. I have everything in here. Now I can go ahead and import Pandas. And let's start loading these files one by one. Let's say df1, so data frame 1, and that would be equal to pandas.read CSV. And then you have to pass the name of the file that you want to open, supermarkets.csv, and just enter. And maybe you want to print that out, so df there. And we got an error. Let's see why. It says supermarkets does not exist. Yeah, I forgot an R here, just there, and this time it worked. So dd to delete that cell. And yeah, what we got here is, so we loaded the data frame first, and then we printed that out, so that we got this table, nice table in there. That's how easy it is to load data from CSV file. Now, if you see this, this is in bold, this first row there. And that's a special row, so that's the header of your data frame. And Python Pandas was able to automatically recognize the header from your file. So this method, the readCSV method, has a header parameter, and that is set to true by default. But if you want, you can set it to none. And that's how you tell Python that my data don't have a header. So what Python will do is it will treat your first row of your file as a simple row, so it will just dump it amongst the other rows. And what it will do, it will create a default header for your data frame with numbers. So I'm going to remove this and leave it as it was. Notice that we also have an ID column there, which if you want, you can use it as an index for your data. So if you want to use ID as an index instead of letting Python define your index, what you do is you apply the setIndex method to your data frame, and then you say ID there, execute, and what Python will do, it will search for the column with name ID, and it will set it as an index. df.1 shape if you want to know the shape of your data frame. So you get 6, 7, meaning that you got 6 rows and 7 columns, including the ID column. And yeah, that's how you load CSV files. Now let's go ahead and load df2 pandas. What's next? Well, next is JSON. So instead of doing read CSV, you want to do read JSON. And then you just pass the name of your JSON file, including the extension, of course. I executed that, I forgot to print it out. So this is a JSON file, and similarly, if you want, you can set the index to ID and execute again. And ID is set as an index. Now you can also notice that the order of the columns is not the same as the previous CSV file that we opened, which is not a problem. Every column has its own name, its own identity, so having columns without an order is not a problem. And let's go ahead and load the XLS file, XLSX actually, an Excel file. So pandas read Excel, and you pass the name of the Excel file. And normally you should also pass another parameter here for Excel files, because you know Excel files might have multiple sheets inside them. So you want to specify the sheet name, which starts from 0, so you need to pass the index actually. If you want the first sheet, you want to pass 0. If you want a second sheet, you want to pass 1, and so on. So I'll pass 0 there. I had only one sheet in the Excel file. df3 execute, and yeah, we were able to successfully read the Excel file as well. Yeah, let's move on with the txt file. So it's a supermarkets separated by commas. So it's a data structure separated by commas. For that, so for txt file separated by commas, again you use read CSV. Just like that, df4, and here is the data frame. So this supermarkets.csv, actually some say it's a comma separated file, but to be more accurate you would say character separated values. So C is for character, and yeah, there might be different characters there. In this case, when you have commas as separators, you don't have to pass any separator parameter here. But when you have other values as separators, you will have to pass that. That is the next scenario. So df5 pandas.read CSV. So we're talking about supermarkets semicolons. Oh, supermarkets semicolons .txt. And yeah, let me try this as it is now. So if I execute that, Python will not be able to recognize the semicolon there. The reason to that is because the separator parameter has a value of comma by default. So you want to change that to your separator, which is a semicolon in this case. Execute. We got an error there, unexpected keyword argument separator. So it seems like read_CSV doesn't have a separator parameter. In that case, you want to ask for help. And yeah, here is the parameters that you want to pass. So it's actually a sep, and you can see that the default value of sep is a comma. So close that and go here, change that to sep, execute, and here is the data frame. Great. What's left to do? We consumed everything, and that's about reading local files. Now Pandas also allows you to read online files directly from the web. For instance, here we have a CSV file in this website. So I browsed to that, and then it was downloaded. And if you want, you can go ahead and put that in your Jupyter folder and then open it as we did. Or you can grab this URL, go here, say df6.read CSV, and then pass the URL just there. df6 to print that out. And boom, here is the file. So it's the same, exactly the same CSV file that we opened earlier up, but we were able to get it from the web. And yeah, similarly you can get other files as well, JSON. You can pass it as URL. Just there, and print that out. And here is the file. So this can be very useful when you want to automate things. Let's say you have some data from a website, from a data provider. Or maybe you have multiple files and you want to write a loop in Python that accesses these URLs, and then it gets the data, and also you then analyze the data and so on. So yeah, that's about loading data in Python via Pandas and using Jupyter. So I believe you find this very easy. And yeah, we'll move on and do some data analysis in the next lectures. So I'll see you there. Alright, now that you know how to load data in Python via Pandas, and you know how to do that using different data sources, as you saw, CSV, JSON, text files, and Excel, and now you want to understand how and learn how to manipulate these data frames. And by manipulation, what I mean is deleting rows and columns from your data frame, and adding new rows and columns, and also modifying existing rows and columns. So that's what you're going to learn throughout these lectures. But first of all, I'd like you to understand how data frames are indexed. And with indexing, I mean, you know, we have this data frame here, and this can be a big one. So this happens to be a shorter one with only 6 rows. But if you have big data frames with lots of columns and rows, then you may want to extract information out of that data frame. And to extract information, you need to have like a coordinate system in that data frame, like an embedded coordinate system. So that if you want to access, let's say, from here and 15 to, and then maybe this other portion, so these 2 rows here, this portion in here, you want to know how to do that. So that's what you're going to learn now, how data frames are indexed and how you can slice them. So let's try to extract that portion of the data frame. Let me create some empty lines here. I don't want to confuse you with that data frame, so we're working on this one. And yeah, df7. And what you want to apply now, there might be different ways to access that portion of the data frame. The first way is to use label-based indexing. The other way is to use position-based indexing. So your data frame has column labels and index labels. So these 1, 0, 1, 2, 3, 4, 5 are index labels, and these are column labels. Now these, the index label, in our case, it's a bit confusing because normally it can be text, such as, let's say, in our data frame, the address is a unique column which you can use as an identifier. So if you want, you can set that as an index. Address, execute, and now you see that this is in bold. So the first column is in bold, meaning that this is the index column of your data frame. So now you can use labels from your index column and labels from your header, your column names, to access portions of your data frame. Just be careful though, because with this operation that we just did here, you know, if you print df7 now, df7, you'll see that you still have the old index column in there, so 0, 1, 2, 3, 5. The reason to that is this set index method, as many other methods in Pandas, is not an in-place operator. Meaning that all this will do, it will spit out an updated data frame, but it will not store that data frame in your variable. So the variable, the data frame, remains the same. it just prints out a new data frame on the fly, just for printing purposes. So what you want to do to store that is you create a variable, which can be the same variable as this if you just want to update your variable, but it can also be another variable like df8. I'll just want to update the existing variable like that, and that will not print out any output, so you want to do that manually like this. So now when you print df7, you see that df7 is updated with this address column as an index of the data frame. So be careful with in-place operations. You know, you can see that df.set index, a question mark to ask for help. Oh, sorry, it should be df7 set index, and you can see that you have this in-place parameter there that is set to false by default. So which means you can also pass in place after this and set it to true, and that will update the existing data frame without the need to save the data frame to a new variable. But I would recommend that just get used to creating new variables when you apply methods to your existing variables, existing data frames, and you should be good to go. Delete that, and yeah, let's get back to our original purpose now, which was to slice this portion of the data frame. I will first do it using label indexing. With label indexing, you want to use a lock in there, so the lock method, and then you pass square brackets in there, and then that gets two elements. And the first element could be a range of the index column. So we're talking about labels, about strings, so you'll have to pass 735 Dolores st, and then a range, so with a column there, 332 heal st, and then from country to id. Execute that, and yeah, this is our portion. So when you use labels, you're including the first label that you pass there and the last one as well, so everything between those. And like here, country and employees is included as well, but ID also. And of course, almost similarly, you can access, single cells from your data frame, just like that. So the intersection between this index label and this column name is USA, which should be this one here. If you want all the USAs, then you just pass everything there and you get everything here, which of course, if you want, you can convert it to a list, so a simple list using the Python built-in function, which is list. And that's about label-based indexing. Now, this is not the common way to extract data from the data frame. More common could be to access data based on indexing, not based on labels. So to do that, you do df7, and instead of lock, you do ilock. That again expects two items. So the first would be the range of your indexes. Actually, let me print out the data frame here so that you can refer to that. So let me access from Dolores to 23rd Street. That would be 1, 2, 3, I believe, yeah. And also from country to ID. So again, 1, 2, 3. And yeah, you can see the difference now. The ID wasn't included there, and either was 23rd Street, because this is, as you do with lists, this is upper bound exclusive. So with Python list, 3 is not included in the slice. But with labels, the last item of the range was included in the slice. So in this case, you want to pass 4 there and 4 there, and that's how you get your portion. And of course, similarly, you can do things like that. So you get all the rows or only one of them. So that would be a row with index 3, which is this one, but only for columns country, employees, and ID. So USA 10 and 4. Oh, right. That is position-based indexing. Now we have one more very useful kind of indexing, and that is combined indexing. So in certain scenarios, you might need to access a portion of rows without having to pass names for the rows. So you want to access rows based on indexing, based on their position. But on the other hand, you don't want to access columns based on positions. You want to access like certain columns which name you know about. So you don't want to count the column. And here comes in handy the IX method. So that allows you to enter a combination of indexes and labels. So that will return you the row with index 3 and the column with the label name. So you get Ben's shop. And you cannot do this neither with iLock nor with lock. That's why IX exists there. And of course you can put two positions if you like. So name would be 0, 1, 2, 3, 4, and you get the same output, Ben's shop. Which brings us to the point that if you want, you can always use IX and forget about iLock and lock. But IX is not recommended over iLock and lock. So these are more explicit, and they will avoid errors sometimes when you do position-based indexing. So I also suggest you use iLock and lock whenever you can. And then switch to IX when you want to do these kinds of combinations between labels and positions. And yeah, that's what I wanted to teach you about data frame indexing and slicing. And I'll talk to you in the next lecture, where you'll be learning how to delete columns and rows from a data frame. See you there. Alright, now you know how to extract portion of a data frame, but how about deleting columns or rows from a data frame? Well, for that, you'd want to use df7.drop, so the drop method. Note that this is also not an in-place operation, so your df7 data frame will not be updated with the deleted column. And yeah, let me delete the city column. You'd pass city for the column name, and then 1. And so the one argument means that you're about to delete columns. That's how you tell Pandas or Python what you're about to delete. When you delete rows, you want to pass 0 there. So, and yeah, here, this is the on-the-fly data frame without the city column there. So again, df7 with city and drop. Let me drop 332 hill st 0. And yeah, hill street is not there. And of course, if you want to update your data frame with the changes, you do that. And then when you print out your df7 data frame, the hill street is not there. And yeah, if you want to drop columns or rows based on indexing, you do a trick like df7 and then point to index. And then what do you want? Well, 0 to 3 maybe. So you're deleting rows, execute that, and you get the 3 rows only. Similarly with columns, and 1 in here. So you get ID, name, and state, the first 3 columns. So if that confused you, df7.index, what that gives you is a series with the names, so with the labels of your index column. So all this. And similarly, columns gives you the names of your columns. So that's how you access the header of your data frame and the index column. And yeah, that was about deleting columns and rows from data frame. If you have questions, just feel free to ask them. And I'll talk to you in the next lecture. Good, we're continuing our series of lectures about manipulating Pandas data frames. So you learn how to drop a row or a column out of a data frame in the previous lecture. Now let's see how we can add a column or a row to a data frame. So we have df7 here with address as index column and this series of column labels. Now just to clarify something, I know this is difficult to wrap up in your mind how you'll be using these operations in real life. So I just want you to know the syntax of doing these operations. And throughout the course, you'll learn how to actually put this into work with real life examples. So don't worry about that. And yeah, let's add a column there. To do that, you'd want to say df and in square brackets, you pass the name of the new column. Let's say continent. That would be equal to, now you would have to pass a list of values that you want to populate that column with. Let's say North America. Now if you execute that, you'll get an error. Name df is not defined. Actually, I didn't mean this error. This was another thing. You'll get this error. So it says that the length of values does not match the length of index. So the length of index is, length of index is df7.index. The length of your index is 5, but you're trying to pass their list with a length of 1. So you've got only one element there. So the solution here is to pass a list with the exact number of items that you have in your table, in your data frame. So we have 5 rows there, 5. And yeah, you could add 4 more items here, North America, etc. Or you can do some fancy things in there. So you could say df7 shape, then 0 times that. Execute. df7, print that out. And yeah, we have a new column. So if you're confused with this shape, 0 times North America, what I did is, df7.shape, what you get is 5, 7, which means you have 5 rows and 7 columns. Now what I want to get is the first item of that tuple. So I get 5 by doing shape 0. With this, I always make sure that I'm getting the number of the rows that my data frame has. And then when you multiply 5 by a list with 1 element, you get a list with 5 elements. America. That's the idea. Delete that. And note that this is actually an in-place operation. So that will update your data frame. And now that was about adding a new column, and how about modifying a new column? So modifying the continent column. That could be something like country, and you can also add some strings in there. Let's say plus a comma, plus maybe another string, North America. Execute that, print out the data frame, and yeah, see what we got. So what we did here is we updated the continent column by referring to an existing column, which was country, and then for each value of the country column, we concatenated the comma string, which you can see in here just after USA, and we also added another string, so North America. And this could also be another column if you liked. So if you passed here, let's say employees, you'd get 8 instead of the first North America, and then 15 and so on. So that's how you update a column. Now, how about adding a new row? Well, this can be a bit tricky, but still understandable. What you could do here, because there's not easy method to pass a row to a data frame, what you could do is you could say df7t, so I'm creating a new variable, that would be equal to df7.t. So t actually is a method that what it does, it transposes your data frame. And with transposition, I mean, df7, if you check your new data frame, what you get is this. So your rows have become columns, and your columns have become rows. So spend a few seconds looking at this. Yeah. And what we can do now is, we can use the same syntax, df7 t, and then add a new column in there. So for the name of a column, you'll have to pass an address. Well, let's say my address. Now that would be equal again to a list. And you want the list to reflect this order. So city first, let's say my city, country, my country, and 10 for employees, and 7 for ID, my shop for the shop name, my state, and my continent. Execute that, and df7t. If you look at this now, you'll see that you get a new column in your data frame. And now what you do so to complete the trick is, let me say df7 equals to df7 underscore t dot t. So df7 now will have the new row added at the end. So let me wrap this up. Again, what I did is I transposed the original data frame df7, and then I added a column there. And now if I transpose the data frame back again to its original position, this column that I added will be converted to a row. And that does the trick. And similarly, you can modify a row if you like. So in that case, you don't point to my address, but you'd point to an existing column with an existing address name. For instance, this one, if I pass it here, and execute that, and that, and you'll see that the values of this row with this address name have been updated now, as you can see in here. And that closes this lecture as well. And yeah, I'll see you later. And yeah, let's close this section on pandas by looking at a real-world example. And in this example, what we're going to do is we're going to grab the address of each of these rows that we have in the data frame. We're going to convert it to a latitude and longitude coordinates. So geographic coordinates in other words. Now, addresses, they define a unique point on the Earth. So if you pass this address to some service, let's say you throw it on Google Maps, and Google Maps will point you, so it will generate a marker that will tell you where this point is located. Now, on the background, that marker actually has a pair of latitude and longitude coordinates. And every point on Earth has this pair of coordinates. And if you follow the section on building web maps with volume in the course, then you know what these latitudes and longitudes, how they come in handy when you build applications such as web maps or other maps. Now, the process to convert from addresses to coordinates is called geocoding. And if you want to convert from latitude and longitude to addresses, that is called the reverse geocoding. In this lecture, we're going to be looking at geocoding. So basically what we're going to do is we'll add here a column to the data frame, actually two columns, one for latitude and one for longitude, for each of the rows. Now, Pandas cannot do that directly, so you need the help of another library that is called GeoPy. And you can install GeoPy with pip. So pip install and GeoPy. And just wait a while. Oh, great. And then, before going ahead and applying the geocoder to my data frame values, I'd like to actually convert a single address, an address string with geocoder. Something you should be aware of is that to use GeoPy, actually to use the geocoder, which is, if you say import GeoPy, and if you say GeoPy, like that, you'll see that you have a geocoder module among them. which is this one here. So geocoders actually. And for the geocoders to work, you need an internet connection, because what geocoders will do, it will get your address and then it will send that to an online service that has all these addresses in a database, and then for your address it will calculate the corresponding latitude and longitude values. So you need an internet connection. And yeah, what you normally do is, you want to import from geopy.geocoders import. Actually, there are a few geocoders there, but we will use Nominatum, which is a tool of OpenStreetMaps. And then what you do is, you create a Nominatum variable object. So you store that object in a variable, and that would be equal to the Nominatum class. So like that. And once you have that object, then you point to the geocode method of the Nominatum object, and then you pass an address as a string in there. Let's say 3995 23rd, then maybe the city and the zip code 94114. And if you execute that, you'll get a location data type there. So all this, and what that includes is, it includes the address that you pass there, so this one, and it has also added the United States of America, so the country in here, and you also get the latitude and longitude. And this one here, just ignore that, it's just a response from the geocoder, so it doesn't mean much. Now, sometimes though, it's rare, but sometimes you may get a non-object. So for instance, if you pass this address, which probably is not a real address, I'm not sure about that, I don't know, but if you say San Francisco, CA 94119, if you execute that, nothing will happen. And actually you can see that if you store this in a variable and then print n, this will say that it's a non-object, so it doesn't have anything inside. So yeah, be aware of these scenarios as well. And yeah, we had our working address, this one here. Let's store that in this variable. Once you have that, to extract the latitude and the longitude, you apply a latitude for the latitude value and a longitude for longitude, and that should do it, because n, type n is a special object, it's called a location object of GeoPy, so you need to apply those methods. And yeah, that's how you convert an address string to a location or to latitude and longitude values. But how about converting an entire column of a data frame into latitude and longitude? So we've got this data frame, df equals to pandas dot read csv, so super dot csv, and this should be an underscore. And let me import pandas first and print out the data frame. So this is our new data frame. Actually, this is the old one that we have been using. We have 6 addresses there, 6 rows with an address, a city and state and country. Now the geocode method, more or less, it accepts this kind of format. So it expects from you the road name in here, and then the city, and the zip code in here, and the country. So what we can do is we need to construct such a column in our data frame first. And yeah, you can either create a new column or you can add it to an existing one. So let's say I'll edit the address, the existing address column. So that would be equal to df address, so this value in here, plus, well, I'll need a comma in there, So a comma and maybe a space, and plus df city, so a comma between address and city, and then another comma, and then plus df state again, and yeah, yet another comma, like that, plus again df, and lastly country. That should do it, df, and yeah, we've got a complete address column in there. Great. And now we need to send this string to the geocode method, and we need to do it for all the rows. You're probably thinking of iterating, but with Pandas actually you don't need to iterate. I mean, Pandas is designed in a way that it allows you, it has some methods that allows you to apply a method or a function to all the rows of the data frame without having to write a for loop. And to do that, you need to create a new column. Let's call it coordinates, where you store the string. This string in here. So this actually it's not a string, it's a location object, but you can store it in your data frame. So we need to store locations for each of the rows, and the way you do that is you point to the column that you want to pass to your geocoder, and then you use a Pandas method called apply. So what method do you want to apply to the values of the address column? Well, that would be n. So n is a nominatum object that we have here. Oh, sorry, it's nom. Sorry. So that would be nom.geocode. And so the same as this one. So nom.geocode. But in this case, you don't pass brackets there, because the apply method will do it for you. So just like that, and then you print out the data frame in there and see what you get. I got a service timed out. The geocoder is not working properly. Maybe I have a problem with my internet connection. So if you get this long error, that is not your fault. It's a problem with the geocoder with GeoPy. I'll try that again. And yeah, this time it worked. It was able to fetch the location objects in here. I mean, you cannot see the latitude and longitude because it's a long string. But if you do it like that, coordinates, you get the series for coordinates, and yeah, that is not showing it either. But you can do it like df coordinates, and then you access the first item only, like that, and then you get the entire text for the location. If you want the latitude, you get latitude only. And that brings us to the point that you may want now to add another 2 columns in your data frame where you fetch the latitude and the longitude values. So our data frame is this one at the moment, and what you could do is you could create a latitude column in there that would be equal to df coordinates apply. You cannot apply latitude directly in there because you'll get this kind of error that says series has no attribute latitude. So you're applying a latitude method to a series, but a series doesn't recognize that. What series recognizes is the apply method. So there you can write your other methods. Now latitude will point to the values of this coordinates column, and in such scenario you use a lambda function, so which is an inline method to build a function. So you'd say lambda x, x is a temporary variable there. You say x latitude. Yeah, let's keep it like that for now. Df there, and let's see what we got. Well, it says that a non-type object has no attribute latitude. So this can be quite tricky if you're not experienced with geocoding. Yeah, the reason we get this is that we have a non-row value in there among our rows, and the non-row, which is not a location data type, does not have a latitude method. Because you know what we did here is we're storing all these values, so it's like a loop. We are storing all these values in the temporary x variable, and then for each of these value we apply the latitude. So what Python will do is it will go through the first row, and it will apply the latitude methods to the first row, and it will store it in the latitude column. And then it goes to the second value, but in this value latitude is not existing for none, so you get an error. To do that, you could apply a conditional, an inline if conditional. You say if x is not none, else none. Yeah, I know it's a bit confusing, but what we did is, you know, apply latitude if x is not none. So it will apply this method for those rows, for those values. Otherwise, it will store none in the current cell of the latitude column. So I hope that is clear. I'll execute here. And yeah, we got the latitude column in there. Great. And we can do the same for a longitude. Longitudes, and here as well. Yeah, that was quick. And yeah, that's it. You have a latitude and longitude column in your data frame. So please have a second look at what I wrote in here. And if there is something that doesn't make sense, just drop a question and I'll be happy to answer you. So yeah, we have quite a lot of flexibility working with data frames. I hope you enjoy this, and I'll talk to you in the next lectures. See you.